Hello, Algebra 1 students. This is part 2 of the first installment of your summer assignments. And start with 4 vocabulary phrases. This word here is being used as an adjective, so it's pronounced arithmetic. That's common in the English language when the part of speech of a word changes, sometimes the pronunciation changes. Like blessed. If we want to say that the priest blessed us, that's a verb and it's pronounced blessed. But if we want to talk about a saintly person, someone along the path to sainthood, is referred to as blessed. So there are probably many other examples in the English language. So arithmetic. An arithmetic sequence and an arithmetic series. And then as a distinction, something different, there are geometric sequence and geometric series. It's only in the last few years that I really came to terms. It always confused me, the difference between sequence and series. And I think this is an example in math where we're taking ordinary words in the English language. Sequence and series are both fairly ordinary words, but we're using them in very specific ways. When we use the word sequence in these cases, it's just identifying the numbers in a sequence. What are they? But when we use the word series, we are interested in their sum. So if you think back to the first video that you watched recently about Gauss and finding the first n, the sum of the first n natural numbers, that was a series. When we listed 1, 2, 3, 4, 5, 6, 7, that was an arithmetic sequence. And then when we asked, what is the sum of 1 plus 2 plus 3 all the way up to 7, that would be the series. So sequence is just identifying the numbers that are in the list or the sequence, and series is we want to add them. Now, as far as the geometric sequence and series, the geometric sequence is covered in Chapter 9, and I'm not going to talk about that this summer. Later in the course, I'd like to come back to all of this and get into the geometric. Geometrics are a little harder, but it is in your Algebra 1 textbook in Chapter 9. At least the sequences are. And as I said in the previous video, this is the topic that I talked about that's near the end of Chapter 3, the arithmetic sequence. Now, in your textbook, they don't get into either one of these series, but we are going to talk about, even though it's not in your textbook, we're going to talk about the arithmetic series today because we're going to use our experience with Gauss as a guide to be able to answer that question. So let's talk about the distinction between an arithmetic sequence and a geometric sequence. An arithmetic sequence might be like this: 2, 5, 8, 11. Now, this is a topic that could be covered in a very early grade, grade 1, right? The grade 1 teacher is not going to call it probably an arithmetic sequence, but the student can be asked, what are the next 3 numbers in the sequence or the list, right? And any young student is going to be able to pretty easily tell you that the next number is 14, and the next number after that is 17, and then 20. Now, why did I start with 2? I arbitrarily chose 2, and that's the first term of the sequence. We start with a number, some number that somebody chooses for us. And then the other part of the sequence is we have to choose how much we add by to get the next term. And by the way, we can subtract as well. The number that you add could be either positive or negative. If it's negative, you add -2, that's like subtracting 2. And that's called the difference. The difference between the terms here is obviously 3. That difference could be a fraction, and of course, if it's a fraction, if we're going up by 1½ each time, or we're going up by 2 3/4, or -2 3/4 each time, it'll be a little bit more challenging, but very simple concept. Pick a number and then pick a difference, a number that we're going to add to each term to get the next term. And there's a formula. And the formula really addresses this question. This was an extremely simple situation that any first grader could come up with those next three terms. But here's where the formula comes in. Here's where the Algebra 1 part of this arithmetic sequence topic comes in. What if I asked you, let's say, this is the first term, this is the second, this is the third, and this is the fourth. What if I asked you to identify the 37th term? And please note here, we're not summing. When summing all the numbers is what's known as a series, and there's those terms of art. When we use the word sequence, we're just interested in what are the numbers. When we use series, we want to add them up. We're not at series yet, we're just looking at sequence. But you see the issue? Do we really want to add 3, add 3, add 3, keep track of where we are until we get to the 37th one? Wouldn't it be nicer if we had a model? Wouldn't it be nicer if we had a formula so that we wouldn't have to grind it out? Okay, and that's the difference between a first grader dealing with an arithmetic sequence and an Algebra 1 student. The first grader would have no choice but to just keep adding 3 and keep track until you get to the 37th one. I'm going to erase what's up here now and start to talk about the formula for identifying. Here's how we're going to put it into words. We want to be able to identify the nth term of an arithmetic sequence, and there is a formula for that. Let's look at the same arithmetic sequence, and your textbook uses the arbitrary letter A to stand for the terms of the sequence, along with subscripts. We read this as A sub 1, A sub 2. Now, we can't just call every one of them A because that would mean that they're all the same number, which, by the way, that's a pretty boring arithmetic sequence if you have, say, 4, comma 4, comma 4, comma 4, comma 4. The 37th term of that sequence would be 4 because the difference is 0. You're adding 0, and that's extremely boring. So we use A sub 1 is the first term. A sub 2 is the second term, A sub 3 is the third term, and so on. And I think earlier I asked what was the 37th term of this sequence, and we'll look at how to come up with that. First of all, in this sequence here, A sub 1 is 2. It's the first term. Why is it 2? Because I chose it to be 2. And then we're going to use a small lowercase d to represent the difference between each term. And the difference between each term is, of course, 3, positive 3. We add 3 to a term to get the next term. And by the way, there's a simple formula. It's kind of useless, though, in my view. It's obvious, but not very useful. Formula in your textbook that looks like this. A sub n equals A sub n minus 1 plus d. Okay? The nth term of an arithmetic sequence is the one before it. Now, this is also, you have to get used to the use of symbolism. If A sub n is the nth number or nth term in the arithmetic sequence, A sub n minus 1 is the one right before that. So all this formula says is to find a certain term, like in this case, to find the 37th term. Let's say we have, let's use n as 37. Right? Well, this formula tells us that A sub 37 will be A sub 36 plus D plus the difference, right? And if n is 37, n minus 1 is 36. Well, that's certainly true, right? Back up here, if we knew what a sub 36 it was, we could just add 3 to it to get a sub 37. But we don't know what a sub 36 is. That's why I say this formula is obvious but kind of useless. Okay? A sub, this is a sub 36, and in our case, we'll also put here, this is a sub n. That's the one we're interested in. We're interested in the nth term. And then the one before it is a sub n minus 1. In this case, the n is 37 and the n minus 1 is 36. But you see the problem? Okay, this d, by the way, this d in our case is 3, right? So this right here tells us that if we know a sub 36, we can add 3 to it to get a sub 37. Big whoop, as you might say. Or does that sound weird coming from me? Okay, big deal. It's not very helpful. So we need another formula. We'll try to develop that. Okay, I've put something down here to help you to see how this formula works, how it's constructed. A sub 1 is the first term, and it's 2. A sub 2 is 5. A sub 3 is 8. A sub 4 is 11. And A sub 5 is 14. We'll go that high for now. And of course, you're always adding 3 to the term before to get the next term. All right? Now, when we look at the second term, which is 5, we take the first term of 2 and add 3 to it. 2 plus 3 is 5. That's pretty obvious. But notice what I did here. I wrote 2 plus 1 times 3. We're only adding 1 3 to the 2. All right? What about how to get to the 8? Well, we could say we take 5 plus 3, but let's go back to the first term each time. And this should make sense to you. To get to the third term, which is 8, we take the first term and we add 2 3s to it, right? We added 1 3 to the 2 to get 5. To get to the 8, we have to add 2 3s because we would go plus 3, that's 2 3s. Okay? So it's 2 plus 2 times 3, 2 plus 6 is 8. To get to the fourth term, going back again to the first, now, of course, the 11 is simply 8 plus 3. But go back to the first term, because we're always going to know the first term. Remember earlier I said it's useless to say add 3 to the a sub 36 because we don't know what a sub 36 is, but we know what a sub 1 is. We know that it's 2, so we're sort of building the model on that knowledge. To get to the 11, well, going all the way back to the 2, you would add a 3 to get 5, another 3 to get 8, and another 3 to get 11. You'd add 3 3s to get to 11. 2 plus 3 times 3, 2 plus 9, 11. Okay. And to get to the 14, you would add 1 more 3. We've already added 3 3s to the 2 to get to the 11. To get to the 14, we add another 3, which makes a total of 4, right? So going back to the original a sub 1, 2 plus 4 3s. 2 plus 12 is 14. See, it's not that hard. But here's the key. This is the key to the formula. Compare how many 3s we add to the term number, right? When we're finding a sub 2, how many 3s do we add to the a sub 1? 1. To find a sub 3, how many 3s do we add to the 2? Well, we don't add 3 3s to get term 3. We only add 2 3s. To go from the first term to the third term, we add 2 3s. You're always adding 1 fewer 3 than the term you're trying to find. Because think of it this way, you don't add anything to get the first term. You just start with 2, right? To get to the 11, 11 is the fourth term. It's a sub 4, 1, 2, 3, 4. But you don't add 4 3s to the 2 to get to 11. You only add 3 of them. And this 3 right here, this 3 is 1 less than that 4. This 2 is 1 less than the 3. That 1 is 1 less than the 2. That 4 is 1 less than the 5. And it continues like that forever. Okay? I think we're ready for the formula. And the question is stated like this: what is the nth term of an arithmetic sequence? Now again, we're not concerned with adding like we were before. That's a little deeper. We'll get to that. What is the nth term of an arithmetic sequence? Well, we were talking about 37. Here's the formula. And the formula depends on, you have to know two things. You have to know the first term, the a sub 1, which in this case was 2, and you have to know the difference. And the difference here was simply 3, right? So this is the useful formula. The useful formula that's in chapter 3 of your textbook. A sub n is the nth term, like right here in this 37 in that case. The nth term of an arithmetic sequence is the first term, a sub 1, plus n minus 1 times d. Here's the thing about math formulas like this. There's a tendency maybe to just look at it and you see all that stuff and get all overwhelmed. Oh, you try to memorize it. You don't have to memorize this. You can figure it out. This n minus 1, we talked about why it's n minus 1. Because you don't add 3 to get the first term. You don't add anything to get the first term. You start with 2. And then you to get the next term, you do 2 plus 1, 3. This is a sub 2. This is a sub 1. And then the next term is 2 plus another 3. So it's 2 plus 2 times 3. This is a sub 3. I did this before. I'm just doing it again underneath the formula to emphasize it. The next term, which is a sub 4, is 2 plus 3 times 3. You see, that's why, see, this is why this here is n minus 1. A 2 versus, a 3 versus a 4, a 2 versus, see? I suppose for a sub 1, you could say, you don't usually see it this way, but the a sub 1 could be thought of as 2 plus 0 times 3. Right? 2 is 2 plus 0 times 3. And this 0 is 1 less than the 1. Okay? So to find the nth term of an arithmetic sequence, take the first term and add to it n minus 1 times the difference. That's the formula. That's the model that we use to find the nth term. Okay, let's look at an arithmetic sequence that a first grader typically will not be asked to handle. But for you entering Algebra 1, beginning high school math students, this is a very easy arithmetic sequence to come to terms with. First term is 3, then -1, then -5. Let me ask you first, what are the next 3 terms? Pause the video until you're certain what they are, if you need to. Right? Isn't the next term -9? And the next term is -13. And the next term is -17. Right? Let's find the 19th term. Now, you could grind it out. You could keep subtracting 4, subtracting 4, and subtracting 4, and keeping track of where you are until you are at the 19th term. But instead, let's be a little sophisticated. Let's be smart, like Gauss. We're not adding things up here, but similar thing. We can use a formula. We can think about the structure. Formulas or models, as I also like to call them, they describe the structure. It's like science. It's like when you're learning that water is made up of 2 hydrogen atoms and 1 oxygen atom, H2O. We're looking at the structure of reality and science. We're looking at the structure of math in these formulas. Well, what is a sub, and here's the formula, by the way. The nth term is the first term plus n minus 1 times the difference. Well, in this case, a sub 1 is 3. And the difference, remember I told you before that differences can be negative. They can also be fractions. The difference here is negative 4. Negative 4 is the number that's added to a term to get the next term. That's known as the difference. And let me just make this connection. You know, it's a perfectly logical word to call the difference, because if you do negative 1 minus, whoops, I wrote negative 14, that's negative 4. If you do negative 1 minus negative 4, you'll get 3. If you go backwards, if you take a term and subtract the difference, subtract the difference, you'll get the term in front of it. And it gets a little weird here with the subtraction of a negative, but if you do negative 1 minus the negative 4, you'll get the negative 1. You don't really need to know that to answer these questions, but I just want to give you a sense why it's called the difference. It's easier to see when the difference is positive, right? If you go 5, 9, 13, 17, this is a sub 1. The difference, of course, is positive 4. Well, 9 minus 4 is 5. 13 minus 4 is 9. 17 minus 4 is 13. That's why it's called the difference. It's not random or arbitrary. Okay, let's just use the formula now to find the 19th term. A sub 19 is going to be the first term, a sub 1, a sub 1 plus 19 minus 1 times d. What I've done here is I've taken the formula, I've plugged in 19 for n, because we're trying to find the 19th term, okay? So a sub 19 is going to be a sub 1, which is 3, plus something times d. Now, d is negative 4. And by the way, here's a little symbolism issue here, ladies and gentlemen. See that d right next to the parentheses? That's multiplication, of course. It's n minus 1 times d. If I just put the d here, the d is negative. You've got to be careful with negatives in many regards. That's not going to do the trick, because that looks like a subtraction, not a multiplication. It's because the d is negative. If the d were positive 4, I could just put the 4 there, but you could easily fix that by putting it in parentheses to indicate the multiplication. So the d is negative 4, a sub 1 is 3. And now, how many negative 4, think about this. How many negative 4s do you have to add to 3 to get to the 19th term? Well, you add 1 negative 4 to get the second term. You add 2 negative 4s to get the third term. You add 3 negative 4. You're always adding 1 fewer of the differences to get to the nth term. Because you don't add any, look at it this way, you don't add any differences to get to the first one. You add 1 to get to the second. You add 2 to get, see? All right, so that's 18. We'll just finish this out now. And of course, we have to follow the order of operations. Don't do 3 plus 18. You got to do 18 times negative 4 first. So the 19th term is going to be 3 minus 72. 18, positive 18 times negative 4, negative 72. So turns out to be negative 69. If you want, the 19 is not that high. I wouldn't ask you to do this if I asked you to find, let's say, the 133rd term. I wouldn't ask you to do it then. But it's 19. Just keep adding negative 4, grind it out, and I guarantee you'll discover that 19th term is negative 69. We'll do one more arithmetic sequence. Using the formula, we will find the 26th term of this arithmetic sequence. Now, maybe you can breathe a sigh of relief. The difference is not negative this time, it's positive. But, come on, I got to challenge you a little bit. The difference is not a whole number, okay? First of all, a sub 1 Well, the first term is 0.5, and the difference is what? Not too difficult to see. It's a decimal, but pretty easy to see that the difference is 0.6. To get a term, you add 0.6 to the one before. The difference is 0.6. Okay, so I've got a sub 1, a sub 2, a sub 3, a sub 4. What about a sub 5? Well, of course, that's going to be 2.9. A sub 6, add 0.6 to this and get 3.5. Add 0.6 to the previous one and get 4.1. So we found the next three terms in the arithmetic sequence. Easy stuff. But we don't want to have to grind it out to go all the way up to 26. So we'll use the formula. The 26th term of this arithmetic sequence is a sub 1, which is 0.5, plus 26 minus 1 times 0.6. A sub 1 plus n minus 1 times the difference. That's how you find the nth term in an arithmetic sequence. Probably the most important thing about this is to understand why you add n minus 1 times d to the a sub 1. And I went through that, tried to get you to see why that's true a few different times. Make sure you understand that. And this goes back to what I said earlier, that you don't have to necessarily memorize this formula. You can just think about how it's structured and recall it for yourself. Just figure it out each time you need to use it, or you can look it up in the book when that's available. All right. So take the first term and add to it. In this case, it'll be 25 times the difference. We're going to add 25.6s. Eventually, started going all the way back to case 1. We have to add 25 of the 0.6s to get to the 26th term. So 0.5 plus 25 times 0.6. 25 times 0.6. Oh, look at that. Comes out nicely, doesn't it? 25 times 0.6 is 15. So 0.5 plus 15. So we just answered the question. The 26th term in that arithmetic sequence is 15.5. Not hard at all. I did it again. That's right. I got carried away. Do any of you think that at some point in your lives, I don't know, doesn't have to be today, I don't know when, but at some point that you might get carried away with a math discussion? You never know. You're young. You may not think that math holds a place in your future. Well, I'm pretty sure it's going to hold a place in the next 5 years of your life, at least, 8th grade and the 4 years of high school. Why not make the journey meaningful? It doesn't have to be drudgery. You put in a little bit of effort to understand things, and it'll be an enjoyable journey, even if math is not in your future. But you're young, you don't know that yet. Don't close those doors. Don't close any doors to yourself now. Let the doors be open. Maybe you'll get to the point at some point you'll want to get carried away with math because you'll enjoy it. You never know until you try. I got carried away. I noticed that we're at 29 minutes now. I want to look at arithmetic series, even though it's not in your textbook, because I want to sort of come full circle and go back to young Gauss. So it's going to be 3 videos this first time. I'm going to go to a third part. And again, it's probably not best to watch all 3 of them straight through. Take breaks, go out, have fun in the sunshine, or maybe it's good to do these in the rain. I don't know, but pace yourself, and I'll see you at the third installment of this first of three summer assignments.